Good day, my friends. You are all welcome back to this class. In our today's talk, we are going to discuss some of the laws of chemical combination. Remember, there are three basic laws that deal with chemical combinations. The first law is the law of conservation of mass. Second law is the law of constant composition or definite proportion, while the third law is the law of multiple proportion. We are going to carry out some experiments, just like what you are seeing on the board, to prove this law. And remember, most of the questions they'll give you in the examination body, they'll give you a table like this, and they will tell you to prove that the law is consistent, the figures you have is consistent with the law. And that's what you are going to take a look at. Like the previous exam they did in WAEC private, this past series, this was exactly similar thing that came out. So you look how it's done. First of all, the law of conservation of mass. The law of conservation of mass states that matter cannot be created nor destroyed in the course of a chemical reaction. They only change from one form to another. Matter cannot be created nor destroyed in the course of a chemical reaction. They only change from one form to another. How do we prove that law? The law is very easy to prove. Let's say if you want to carry out the law, what all you need, the materials you need a conical flask, you need the twine, you need the rubber, and you also need solutions such as silver triazonitrate 5 and sodium chloride. Then you need a weighing balance. With that, you are okay. So let's say you have this how you carry it out. You have a conical flask of this form. You place them on top of a weighing balance. Let's take this as our weighing balance. Weighing balance. You have another one. The same size. This is another weighing balance. To measure the weight. Any other instrument you know is necessary for weighing, the two are the same. Then you bring a test tube. You tie this place. You can put the solution here as AgNO3. Then what is here will be NaCl, sodium chloride. While this one is sodium triazonitrate, silver triazonitrate 5. You do the same thing. It's the same. Both of them are the same anyway. It's the same conical flask we are dealing with. So, what happens is, a brief description. Having set up the apparatus like this, just one apparatus, it's not two. This test tube contains silver triazonitrate 5, which is colorless, while this solution contains sodium chloride, which is also colorless. What you do with this string, you pull it. As soon as you pull it, the content of this one, which is the silver triazonitrate 5, pours into the sodium chloride. It is sodium chloride that is here, as we already said. So it pours into this, and immediately it pours into it, you have here a white precipitate. You see it, white precipitate of silver chloride. Then, apart from that, you also have another solution of sodium triazonitrate 5, NaNO3, aqueous. This one is solid. So that is what you have. So this is the kind of equation you will have. NaCl plus AgNO3. Na NO3 aqueous plus AgCl solid. That is what you have. So this is how you carry out experiment to prove the law of conservation of mass, which again states that matter cannot be created nor destroyed in the course of a chemical reaction. They only change from one form to another. What do you mean by that? You can see both of them are in aqueous form. This one is aqueous. Then now you have solid. You have aqueous here, and you have solid here. That is how the law is. Now, it just by pulling the twine, this thing pours into it, and you have this product. Now, what do they actually mean? You can see the product you have. If you calculate the molecular mass of this and molecular mass of this, what you have will be equal to the molecular mass of this and molecular mass of this, showing that matter has not actually been created or destroyed. You only change from one form to another, from aqueous form to solid and aqueous. That is how you prove the law of conservation of mass, and that is what you're required to do. So sometimes they can tell you a given mass of like this 51, 23 plus 35.5, 58 point, let's see. Sodium is 23, we already know that, plus 35.5 will give you 58.5. 58.5, you add it to this, silver is 108, 14, 48. The mass you have, some of the mass you have will also be equal to the sum of the masses you have here, meaning that you have not created atom, neither have you destroyed it, you have just changed it from one form to another. That supports the law of conservation of mass, and that is what you are expected to know. Since we have finished the first one, let's have a space where we can do calculations for the second one. Now look at this. This one is known as law of constant composition or definite proportion. This law states that all pure samples of a particular chemical compound contain the same element combined together in the same proportion by mass. They are always the same. Now, what they will give you in your examination body, they will fill all this place. You just be told to calculate it. That's what came out in that previous exam, and this is how it's usually done. So you look at it. Mass of dish is 2.50. Remember, dish is just empty dish. The ordinary dish or container is this and this for these two samples. This experiment was carried out by heating copper oxide. You cannot it can be, yes, copper, by heating copper oxide or carbon for a very long time until it gave copper from it. So you have mass of dish 2.50, and this one is 2.70 because they use different samples of copper. This sample, A sample, both of them were heated strongly. Then you have mass of dish plus copper 2 oxide. You have this and you have this. Then mass of dish plus copper alone. You have this value and this value. Then what I'm going to explain to you, instead of just giving you the values, is the mass of copper. How do I calculate mass of copper? You're already giving us mass of dish plus copper, so I'll remove mass of dish from it, meaning 2.5, meaning 3.42 minus 2.50. It's not hard. 3.42 minus 2.50. 3.42, which is dish plus copper minus just dish, 2.50, which case you have 0.92 gram. Then for the second one, the different copper entirely, 3.85 minus 2.7 minus 2.70 give you 1.15 gram. The mass of copper oxide, copper 2 oxide, you remove this mass of dish plus copper 2 oxide, remove dish from it, so it will now be 3.65. Just follow the processes. 3.65 minus 2.50 will give you 1.15. So here you have 1.15 gram. Do the same thing to the other one. You have 4.14 minus 2.7 give you 1.44. 1.44 gram. So the next thing you have to do is to calculate the amount of copper in this sample. In your exam, what they normally say, they will tell you mass of dish plus sample. At least that's the exact what they used for the previous exam. Mass of sample. You see it. Sample contains copper and the oxide in it. So copper 2 oxide. So you now say mass of copper, percentage of copper in the sample is 0.92 over 1.15 times 100 over 1. This is for sample A. Then for sample B, this is for sample A. For sample A. Then for sample B, percentage of copper will be 1.15 over 1.44 times 100 over 1. Gives you this, gives you that. So let's see what we have. 0.92 times 100 give you that, give you 92, divide by 1.15 give you 80. So here we have 80%. For the second one, 1.15 times 100 give you 115, divide by 1.44 give you 79.86. 79 point, let's say 0.9. 0.9. So let's divide by the smallest, the number of moles, or just say moles, divide by the smallest. 80 over 79.9 ratio, that is sample A ratio sample B, ratio 79.9 over 79.9. Automatically this one is 1, it's dividing itself. Then let's see the other one. 80 divided by 79.9 give you 1.00125, making 1. You see it is 1:1, which is consistent with the law of constant composition, which states that all pure samples of a particular chemical compound, no matter the source, contain the same element combined together in the same proportion by mass. So the proportion are the same, meaning it is pure. Now let's go to the other one, law of multiple proportion. Law of multiple proportion states that when two elements A and B, I will explain it here better. When two elements A and B combine to form more than one compound, different masses of B which combine with a fixed mass of A are a simple number ratio. Let's say we are using carbon 2 oxide and carbon 4 oxide, CO and CO2. You see it. When two elements A and B combine, this element A, element A, element B, element A, element B. When two elements A and B combine to form more than one compound, in this case it's forming carbon 2 oxide, and the same combination give you carbon 4 oxide, which are different compounds entirely. Different masses of A. You see the mass of A here is 16, mass of A here is 32, which combine with a fixed mass of B. This is 12. Let's say this 16. Let's give you space. 32. This is 12 and this is 12, which combine with a fixed mass of B are in simple number ratio. They always cancel themselves to be 1, 1. This one is 32, 16 here 1, 16 here 2. They are simple number ratio. That is what the law is telling us. When two elements A and B combine to form more than one compound, different masses of A which combine with a fixed mass of B are a simple number ratio. So let us apply it to this. In applying it to this, normally they also give you the values here. But in case you are not giving, that's why I have to leave space for it. You have to sort it out yourself. But it's not tedious. You remove mass of the dish from the mass of the compound you are looking for, and you from the mass of dish and compound, so that you have only the compound you are going to use to work. Now, this same thing similar to this. Two compounds of carbon. This carbon 1 oxide and carbon 2 oxide. They were all heated strongly till the oxide were actually removed. Now, the values they have is this. This is the table they will give you, and you to prove that is in accordance. What the value you have is consistent with the law of multiple proportion. What you do again, you do the calculation by yourself, even though they may give you, in case you are not giving, this is what you need. Now look, mass of empty dish, and here we are, our calculation starts with mass of copper. Mass of copper. I know that mass of dish plus copper is this. Therefore, mass of copper will be dish plus copper, which is 7.08 minus 3.55. We subtract this. Let's see what we have to do the subtraction. 7.08 minus 3.55. 3.55. We have 3.53. 3.53 gram. Then let's do this. The other one. 6.00. 6.00 minus 3.75. 3.75 will give you 2.25. 2.25 gram. That is what we have. Then mass of oxygen. You see that we have mass of this plus copper oxide. We cannot specify whether it's copper 2 or copper 1 because there are two different compounds. It's copper 1 oxide, copper 2 oxide. So we just say copper oxide. Better off. Mass of this plus copper oxide is 7.73. 7.73. Then mass of this plus copper. If you remove mass of this plus copper from it, you are left with oxygen. So mass of this plus copper is minus 7.08. You see it. That is for the first one. We are doing it separately, so we can remove it. We want to have calculated somewhere anyway, it's the same thing. So let's see, we'll remove it. 7.73. 7.73 minus 7.08. 7.08 give you 0.65. 0.65 gram. They also do the same to the other one. The other one is also mass of copper 6.83. Let me just use the base. 6.83 minus 3.75. No. 6.83 minus the one of copper and oxide 6.00. Yes, 6.00. You have 6.83 minus 6.00. 6.00. You have 0.83. 0.83 gram. Having had that, then you can now do the calculations which they expect from you. Mind you, this was the one that came out before. This current one you are looking onto, or you are preparing for, you may likely have this. But I believe that one of them may likely come out of this loss. So you now say oxygen, this is the amount of oxygen that produces this. You say 0, let me remove this. So there will be more space to do our calculations. So 0.65 gram of oxygen produced 3.53 gram of copper. Remember, based on this law, from what I did here, one of them must be constant, because the law says that when two elements A and B combine to form more than one compound, different masses of A, these are different masses, we combine with a fixed mass of B, they always cancel out. If it is 10, 10, 10, cancel out to 1, a simple number ratio, meaning that 1 is constant. I will normally take oxygen as constant. 0.65 gram of oxygen gave this. Therefore, 1 gram, because they must always give you 1 at the end of the day. 1 gram of oxygen will give you X. Cross-apply the normal method. S times 0.65 equals 1 gram, 65 gram, equals 1 gram times 3.53 gram. X equals 1 gram times 3.53 gram over 0.65 gram. This gives us 0.65 divided by 0.65. 0.65 give you 5.61 or 5.62. 5.62 grams. That is for this. Then For the second one, let's move to this side. For the second one, 0.83 gram of oxygen gave 2.25 gram of copper. Therefore, 1 gram of oxygen, you already know why we call it 1 gram, because the constant one give you X. S times 0.83 gram equals 2.25 gram times 1 gram. S equals 2.25 gram times 1 gram over 0.83 gram. It give you, let's see what it goes, what it gives. 2.25. Remember here, gram we always go with gram, meaning 1 gram. 2.25 divided by 0.83 give you 2.71 gram. So the first one gave us 5.62 gram ratio, while the second one gave us 2.71 gram. So divide by the smallest, 2.71 ratio 2.21. 2.71. This one automatically give us 1. Let's see what the other will give us. 5.62 divided by 2.71 give you 2.0. So it give us 2. So you see that it's inconsistent with the law that when two elements A and B combine to form more than one compound, different masses of this compound, copper, which combine with a fixed mass of oxygen, 16, and you give us 1, 1. Are a simple number ratio, 2 to 1, not 1 to 1,000, not 1 to, so therefore it's inconsistent with the law of multiple proportion. Please go through it very well and really master it. On your own, you can remove these values and try to incorporate, try to solve it and see whether you can have those values. So that whichever way is twisted, you're able to handle it. Thank you very much.